Okay, so another good time video, and we're going to do 0607 s14 QP61. So that's a paper 6. We're probably going to split it into two sections. Remember that we're going to be using our calculator. I'm not going to show the calculator on screen for this one because we're not going to do a huge number of complex calculated things as we would do on, let's say, an FX graph or something like that. But in some of the other papers, we might do it where I show you the video with the graphical calculator integrated. So, main thing to remember with these papers, paper 6s, is it's just a case of follow the instructions and do what it says. So, first question is a nice straightforward one. Remember, there's only 20 marks, 45 minutes of 20 marks. That's the best minutes per marks you're going to get in any of your papers, paper 2, 4 and 6. So first thing we need is the factors of 6. It tells you there's 5. So 16 is 1 and 16, 2 times 8 and 4 times 4. So we need a 4, an 8 and a 2 because it says ascending, which means smallest to biggest. Write down the 5 factors as powers of 2. The first one's done for you. Well, of course, this is 2 times 2 times 2 times 2. 4, we should hopefully know, is 2 times 2, which is 2 squared. 2 is obviously 2 to the power of 1 because it's just itself. And you see it goes 0, 1, 2, therefore it's going to be to the power of 3. So it's going to be 2 to the power of 3. Then it says the 4 factors of 27 as powers of 3. Now, here's where you can use a little bit of common sense. Looking at the pattern here, you can guess what the first one's going to be 3 to the power of 0, and you can guess that this one's going to be 3 to the power of 3, 3 to the power of 1, and 3 to the power of 2. And you can just check that. That's going to be 3. Sorry, it's not going to be 3, it's going to be 1. Then you've got 3, then you've got 3 times 3 is 9, 3 times 3 times 3 is 27. Okay, next one. P is a prime number, so we should hopefully know our prime numbers. You should be learning these as a little list in your head. You should just be able to list, let's say, the first 9 prime numbers certainly. So it says write down the 6 factors of p to the power of 5 as powers of p. Well, again, we can use this pattern here. So we can see we've got p0, p1, p2, p3, p4 and p5. Again, it's following that pattern of powers. Write down in terms of n the number of factors of p to the power of n. Now this one is one where you've got to start, so we're, I don't know, 5 questions in, and now we've got to start doing some thinking. So it's saying how many factors are we going to have if p is a number and n is the power. It's saying, okay, well, how many factors are we going to have? Now, when you've done your product of prime factors, hopefully you can remember how to do the number of factors from your product of prime factors. When you're doing this, you need to think, let's say here, for example, we had 3 and 27. We can see it's 3 to the power of 3. There were 5 factors here, and it's 2 to the power of 4. So it's always going to be 1 more. Yeah, because 3 plus 1 is 4. And 4 plus 1 is 5. So it's going to be n plus 1. 1 more than this number. 78,125 is 5 to the power of n, where n is a prime number. Find the number of factors in 78125. Do not write them out. First thing we need to do is we need to find 5 to the power of n. So we do, again, you've got your calculator, 78125. Divide it by 5. And you know, okay, and keep obviously dividing it by 5, dividing it by 5. So obviously you're going to get 15625. Then divide that by 5. And then you're going to get 3125. Divide that by 5. 625. Then you get 125. Then you get 25. And then you get 5. So you've got 5 to the power of 1, 2, 3, 4, 5, 6, 7. So 5 to the power of 7 is equal to 78125. You also could have done this is by putting in 5 and finding out this number on your calculator and substituting values in. If you know that 5 to the power of 7 is 78125, and you know it's always 1 bigger, then you can just say it's going to be 7 plus 1, so it's going to be 8. Because it's, now notice these questions are all linked together. We've got that pattern of 0, 1, 2, 3, 4, 5. Then we've got 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, 1. We've got the same pattern in every question. Okay, let's keep it rolling. 20 is not a prime number. So again, it's talking about the same sort of things. We're talking about factors, then we talked about prime numbers, now we're talking about prime numbers again. The whole paper leads into itself. So 20 is not a prime number because 2 and 5 are factors. Find all the factors of 20 by completing the table. So again, we're just looking for a pattern. 1 times 1 is 1, 2 times 1 is 2. 2 to the power of 2 is of course 2 times 2, which is 4. And again, this one here, 2 to the power of 0 is 1, anything to the power of 0 is 1. Anything to the power of 0 is 1. 5 to the power of 1, so anything to the power of itself, 1 is itself. And then you've got 2 times 5, which is 10, and then 4 times 5 is 20. So it's got 3 rows and 2 columns. Describe how to find the number of factors of 20 from the number of rows and the number of columns. Well, here we've got 6 factors, 3 rows, 2 columns. There's 6 factors. So the number of rows times the number of columns, can't spell the word, equals the number of factors. Anything along those lines. Finally, 2 to the power of 5 times 5 to the power of 3 is equal to 4,000. So find the number of factors of 4,000. Well, if we were to draw the columns and the rows, let's say I had the 5s on the left, I'm going to have 5, 0, 5, 1, 5, 2, 5, 3. So I'm going to have 4 columns. And then on this one, I'm going to have 2, 0, 1, 2, 3, 4, all the way up to 2 to the power of 5. Oh, God, that was terrible. 2 to the power of 5, so I'm going to have 0, 1, 2, 3, 4, 5. So I'm going to have 6 columns and 4 rows. And so you multiply them together and you get 24. Question 4. 1 million is equal to 2 to something times 5 to the something. This is where you do your prime number tree. Or you say, well, 2 times 5 is 10. 10, we need 1, 2, 3, 4. So it's 10, 100,000, 10,000, 100,000, and a million. That's 1, 2, 3, 4, 5, 6. So n is going to be 6 because you need 6 of each. One of these makes one of these. You've got 1, 2, 3, 4, 5, 6 tens. So how many factors are there going to be? Well, it's going to be 2 to the power of 6 times 5 to the power of 6. So there's going to be 7 rows and 7 columns. Again, coming back to this idea here of one more. 7 times 7 is 49. And finally, find n such that 10 to the power of n has 900 factors. Oof. So, you know that it's going to be something plus 1 times something plus 1, because it's going to be the same number twice, and that's got to equal 900. So that means that n plus 1 squared is 900. So we square root both sides. So n plus 1 has got to equal 30. So n is going to equal 29. I know obviously it can be plus or minus, but we know we're going to have positive. So n is 29. 29 is the answer. We're almost through the first section. Okay, x has exactly 2 prime factors, 3 and 7. It can be written as 3 to the power of something times 7 to the power of something. Find possible values of x that has exactly 12 factors. So, 12 factors is going to have to be 3 rows, 4 columns, 2 rows, 6 columns, or 1 row, 12 columns. Just like back in this question here. So 3 combinations. So find all the possible values of x. Well, x can be a number which is 3 to the power of 3 times 7 to the power of 4, or 3 to the power of 4 times 7 to the power of 3, 3 to the power of 2 times 7 to the power of 6, 3 to the power of 6 times 7 to the power of 2, and 3 to the power of 1 times 7 to the power of 12. But obviously we have to subtract 1 from all of them because we know that we always have to subtract 1, which is what we were doing here. Well, that means that 3 to the power, that can't work because that would give you 3 to the power of 0. So when you're doing this one, you say, okay, well, which one of these are going to work? Well, if you were to use the ones that you got left, that's going to give you 4 numbers. So, because obviously we know that we can't use the ones with 1 row. So there's 4 options. How many possible values? There's 4. What are the possible values? Well, you do the calculations on your calculator, and you're going to get 1323, 1701, 3087, and 5421. And that's just those 4 options there. Okay, almost done. Question 6. Write 336 in the form p to the power of something times q to the power of something times r to the power of something, where they're all prime numbers. Well, 336, hopefully we can see, can be divided by 3 and 112. So p, one of the numbers has to be 3. We then split up 112, or we could split it up into 2 and 56. So one of the numbers, let's say, has to be a 2. Doesn't matter, the order isn't important at this point. 56 can be split up into 8 and 7 is a prime number. So p, you're going to have, you need a 2 and a 3 and a 7, but we need 7 of them. 8 we can see here, 8 is equal to 2 times 2 times 2, so that gives us 1, 2, 3, 4 2s, a 3 and a 7. And then hopefully we can see 4 minus 1 is 3, and then we're going to have, so it's going to be, how many columns we're going to have? We're going to have 5, we're going to have 2 and 2, times those together, 5 times 2 times 2 is equal to 20. Last question of the first section. We've got 3 factors, exactly 12 factors. So again, 2, 3, and 5. That's 1 of each. If we just had those, that would be 1. That would be 2. Oh, that's not a 2, is it? 2 times 2 times 2, which would be 8, but we need 12, so we need to add something in here. So one of these needs to be bigger, because we need one of them to be a 3. So it can either be 3 times 2 times 2, 2 times 3 times 2, like so, to make the 12. That's a 2. So therefore, we know it can be 2 to the power of 2, or 3 to the power of 2, or 5 to the power of 2. And then all the other ones are going to be the same. So if it's 2 to the power of 2, it will be 3, 1, 5, 1, 2, 1, 5, 1, 3, 1, 2, 1. Times these together, it's going to be 4 times 3 times 5 is 60. Then you've got this one is going to be 9 times 2 times 5 is 90. And finally, 25 times 3 times 2 is 150. And that's your answer. Okay, so that's the end of the first section. I'm going to split the video in two, and I'll do the modelling section in the second half of this video.